Okay, so let's solve the solution for the quiz. I asked you to do everything, D, P, and P inverse. So the first thing we have to do is step 1, find the eigenvalues, so the characteristic equation. It was not a triangular matrix, so you had to calculate something, but it was not bad, right? So subtract lambda from the diagonal. And that's this, and then 10, 0, 0, 2 minus lambda. And this we put equal to 0. We see, if you pay a bit attention, you see that row 3 is a perfect row to expand for, because we have only one non-zero element, 2 minus lambda, and then what is left is a cofactor minus lambda 0, 2, 2 minus lambda, and that is then, so we have 2 minus lambda, the product of the diagonal elements, and the off diagonal is 0. So this is equal to 0, and we see that the two roots, lambda is 2 and lambda is 0, but lambda is 2 appears twice. So we're going to have to have two of those eigenvectors in the eigenspace for lambda is 2. So let's do this first. Okay, so how you get that? We put lambda equals 2, and the matrix that we get is then the matrix that we have to find the null space of. So that is minus 2, 0, negative 10, 2, 0, 10, and 0, 0, 0. Whenever you can factor out things, it often pays off to do that. So we can factor out a half in both. And then we are left with 1, 0, 5, and also 1, 0, 5. And it's now clear that if we subtract row 1 from row 2, we get an extra 0 row. We get 1, 0, 5, 0, 0, 0. And the rest is also 0, 0, 0. Okay, so what is the deal? This is our free variable, and the two other ones are the it's a pivot variable, and the two other ones are the free variables. So they are the free. Okay, that means that we can write x1, x2, x3. That's what? x1, from this it is 5 times x3. x2 is itself, and x3 is itself. So x2, we have 0, 1, 0, plus x3, and we have a negative 5, 0, 1. Be a bit careful, or I'll copy it later on. Okay, so we have the two basis vectors that we want to have. So what about eigenspace for lambda equals 0? That of course just means the original matrix. So that was the matrix 0, 0, negative 10, 2, 2, 10, 0, 0, 2. So we have to find the reduced echelon form from that. We can again divide by the right numbers. So to get everything, we can divide the first one by 1/10 or minus 1/10, the second one by 2, and the third one by also 2. And this gives me 0, 0, 1, 1, 1, 5, and 0, 0, 1. Now I have to switch these two rows. So row 1 with row 2. This gives me 1, 1, 5, 0, 0, 1, 0, 0, 1. Then subtracting row 3 minus row 2. This pivot here gives us 1, 1, 5, 0, 0, 1. And then the rest is a 0 row, so we don't have to write it really. Okay, and then finally, this is echelon form but not reduced, so we need this one here. So we're going to do row 1 minus 5 times row 2, and what we get is, I'll go back into black, is 1, 0, 1, 1, 0, 0, 0, 1. Okay, so what does this mean? It means that we have two pivots, x1 and x3, and one free variable, x2, that's the free variable. So if we write everything in terms of this free variable, then we see that x1 is minus x2, x2 is just itself, and x3 is actually just equal to 0. So we get x2 minus 1, 1, 0. Okay, so we are done. Step 3, we can build our P. And P is, well, as we build P, we build what is there. I should also be careful that whatever I put in P, I have to in the right order put also in D. I can choose what I put in P first, but let's stick to what we have. I'm going to put these two first, so 0, 1, 0. Again, I could switch them around. There's really no reason to do one or the other. Minus 5, 0, 1. And when these both correspond to 2, that I have to make sure that that they match. And then the last one is this one, minus 1, 1, 0, this one here, and that is eigenvalue 0, so the rest is 0, 0. Okay, so that's P, but we need also P inverse. Be very careful with that. So we copy P and then put the identity matrix behind it. Let's copy it first. Okay. We have a pivot in the first column, but it's not in the right row, so we have to switch these two rows. Talking about this guy. Okay. What is this? No, I didn't want that. Where did I go? So I get 1, 0, 1, 0, 1, 0, and then 0, negative 5, negative 1, 1, 0, 0, and 0, 1, 0, 0, 0, 1. Okay, that's a good pivot. I should now also exchange. For some reason I'm in the wrong. Okay, my primary colors. I want to have this one up, because then I don't have to worry about fractions. So read row 3 with row 2. I get 1, 0, 1, 0, 1, 0, 0, 1, 0, 0, 0, 1, and then 0, negative 5, negative 1, 1, 0, 0. Okay, so I can use now this pivot to make the number underneath of it gone. So that row 3 plus 5 times row 2. So I'm going to multiply this with 5 and add up to that one. So I get 1, 0, 1, 0, 1, 0. Making sure that I don't make any silly mistakes here. I have still everything, okay, yeah. So then we have 0, 1, 0, 0, 0, 1. So I'm multiplying this with 5 and add up there. So 0, 0, negative 1, 1, 0, and that gives me a 5 there. That should have, this last one should be, so row 3, replace that at minus row 3 because I need a plus 1 there. So that would be 0, 0, 1, 1, minus 1. Minus 5, okay, so let's get rid of that. And now I can use row 1. It's echelon form but not reduced, so I have to get rid of this one. So row 1 minus row 3, but the new one. So that would be 1, 0, 0, 1, 0, 5. No, there's a 1 here, right? So 1, 1. Okay, subtract that, yeah, okay. So then we have, and the rest stays as it is. Okay, so this is now P inverse. So now let's test that everything is correct. So we have 1, 1, 5, 0, 0, 1, minus 1, 0, negative 5. And then the original matrix that was, I'm just going to copy it here. 2, 2, 10, 0, 0, 2. And then P, okay, I have to make sure that I get the right P, not like last time where I got the wrong P. Okay, it's this one, right? 0, 1, 0, minus 5, 0, 1, minus 5, 0, 1, and minus 1, 1, 0. Okay, so let's multiply. I'll multiply these two out again. So I get 0 plus 2 plus 0, 0 plus 2 plus 0, minus 10 plus 10 plus 10, so actually 10. We get now the second row, 0, 0, 0, 0, 0, 0, and minus 0, 0, 2. And the final row, I get a 0, 0, 0, 0, 0, 0, and then 10 plus 0 minus 10. That's also a 0. Okay, and so we have to multiply this now with this guy. So what we have, the first row, 0, 2, that's a 2, and minus 10 plus 0 plus 10, minus 2 plus 2 plus 0, that looks promising, 0, 0, 0, 0, 0, 2, 0, 0, 0, and then the last row, well, that's all zeros, so that's going to give me a 0 row. And that's exactly the D I wanted. Okay, so it's good that you test this, because it's very easy to make little mistakes, and if this is not correct, you know something went wrong.